So I'm here to give you a brief overview really of embodied carbon and really focusing on embodied carbon because embodied carbon is one of the main components of the carbon debate and decarbonising construction. And the property and construction industry really does need to focus on embodied carbon if they're going to be successful with the targets of contributing to the solution that we have at the moment against the fight for global warming. But first of all, just to give you a bit of context, I want to talk about 11%. 11% is the total global emissions every year that the embodied carbon relating to the property and construction industry in the built environment contributes to the world's emissions. So 11% of all the emissions in the world are directly related to embodied carbon within the built environment. So the property and construction industry has a really good opportunity to tackle a very large chunk of what is the current problem globally. So the importance of measuring embodied carbon. Well, if embodied carbon is to be reduced, we need to measure it in a reliable way. We need to understand where it is in the built environment. And the property and construction sector has a key role in helping to minimise embodied carbon throughout the asset life cycle. So not just during construction, but into the operational phase of a building and then all the way through to its disposal. So current methodologies and approaches, if we are to talk about when to tackle it, we can see here the typical life cycle of an asset. From the production stage, the extraction of raw materials, through to getting onto your construction site in stage 2. And then stage 3, which is broadly split into two sections, which is your operational energy use, which is a big chunk, that grey part of the circle. And then the actual operational, the activities associated with the use of the assets, business activities, for instance. And then finally, the end of life. So you can see stage 1 and stage 2 actually account for around 41% of all of the carbon emitted within the asset life cycle, and that's before the first day of it being used for anything at all by anybody in any occupier. And then you've got a further 42%. I mean, these are rough percentages, but you can see there that the equivalency between the actual energy used and the carbon emitted within the stage 1 production and construction phase are almost equal. And we talk quite a lot about the emissions to do with operating buildings, installing solar panels, reducing our energy use. Most of that is retrofits. Some of that can be implemented in the design phase, but a much greater or perhaps equal opportunity is actually to impact reduction in carbon during the production and the construction phase. So I think later we have a talk about the construction site and how to decarbonise construction sites. That is a very important stage. But also you see that production stage, and where we're talking about materials and specifying materials and perhaps not over-specifying, specifying low carbon materials, that can really have a huge impact because that accounts for about a third of the asset's life cycle carbon emissions. So where to tackle it? If we look at a particular asset, a typical built asset, and I think this is a typical high-rise office building example here we have, you can see that the building services account for around 29%, that grey chunk of the cycle there. So the embodied carbon within the asset life cycle is really focused on building services. But also what is sometimes forgotten about is the structure. The substructure and the superstructure actually account for 44% combined. And it's in the structural elements of buildings that we can really reduce the carbon impacts of a building's life cycle. And the way we do this is not through retrofit. There are limited opportunities to do this through refurbishment, but really where we're looking at is in the design stages and again specifications and understanding low carbon materials and making sure that we use those low carbon materials and making sure that designs are efficient, not over specified, fit for purpose, and that we don't copy paste designs. I think in Dubai we're perhaps a little bit guilty of perhaps copy and pasting designs. You see a lot of buildings that are almost cut and paste, the same buildings on each site, and there's a lot of economic benefits to doing that because you don't have to reinvent the wheel, for instance. But if we are to reduce carbon, we really do need to take a deep impact look at the structural elements and the materials that make up the structure, so that we can really make an inroad into reducing the carbon impact of the asset. There are some internationally recognised methodologies. There are many methodologies. There is some disagreement over a common methodology, but the main ones really are from the Royal Institution of Chartered Surveyors in the United Kingdom. Although they have a global presence, they are based out of the United Kingdom. And that's where a lot of the groundwork has been done for undertaking surveys and adapting methodologies for different asset types for well over a decade now. So they really have got a head start on this. And there's some good data and some good tools coming out of the United Kingdom that have got a practical application. And they've really shown some good examples of lowering carbon impacts of buildings at the design stage. And then we've got some other two methodologies there. iStruct, now the Institute of Structural Engineers, I'm talking about structure, so there's no coincidence that the Institute of Structural Engineers have also recognised that they have an important role to play and have developed some good methodologies for measuring embodied carbon and guiding people of how to reduce it. And also, I touched on building services, so likewise the Chartered Institute of Building Service Engineers, CIBSE, also have some good methodologies as well. So those three institutions, between them, really are leading the way in terms of dictating how we should measure embodied carbon, where it should be measured, and giving us really good guidance of how to decarbonise built assets. It doesn't come without challenges. The availability of regional data here is very limited, and that's mainly aligned with the lack of environmental product declarations. There are very limited benchmarks available. Traditionally, the methods of measuring embodied carbon that I spoke about just now from the RCS, etc., really in the early design stages use benchmarking, have to rely on benchmarking because limited design information is available. Now, benchmarking isn't really available here in the Middle East because we have limited case studies and examples and data to draw from. Obviously, the more we go through this process, the better that will be, and the more data we'll have to be able to use. So we really do have to start doing this to enable us to do this better in future. We have to start somewhere, and starting now is great. As we go into the design stage and we get into more schematic and detailed design, we can get more material quantities and we can apply carbon rates to those material quantities and have a better understanding of the embodied carbon rates within a particular design. Also a challenge here is the complicated supply chain. Obviously we are in the Middle East and a lot of the materials are imported. They have long supply chains, but also complications in the supply chains just between regions, countries, and even project level. I mean, if you look at Saudi Arabia, the various giga projects which have their own problems just within a project level, let alone the country as a whole. And again, there's no real industry agreement on a universal calculation methodology at the moment. There are plenty of current tools and technical solutions available. These are just a few. Most of these tools don't address the full asset life cycle, but they do focus in on particular elements of an asset life cycle. I've put a few up there, one of which is AECOM's Eco0 tool. We've developed that to target structure, and we've also aligned it with our cost teams so that we can really understand how embodied carbon design implications affect the cost of a project as well, which obviously is something that's very sensitive at the moment. So I won't talk about all of those tools. There are lots and lots of tools. Lots of companies are coming up with their own tools as well. But the main thing to take away is that there are lots of tools out there and they are doing an extremely good job at allowing us to measure embodied carbon. So just in summary, just to wrap up, tackling embodied carbon must be considered as part of any solution to the current climate crisis. There are challenges to embodied carbon measurement, which really demand a level of professional competence if we are to overcome them. And many tools do exist to allow embodied carbon to be measured. They really do help us and the property and construction industry to identify and reduce those emissions.
When you talk about benchmarking, and you say, they're limited in this region, and people have been talking about this for some years now. So how do you get it going?
Well, traditionally, you have to state which methodology you're using, and there are benchmarks available globally. So depending on which asset category you're looking at, there are some global data points that you can look at to give you guidelines. And while those guidelines won't be necessarily relevant, particularly in absolute terms to the Middle East, they are useful in terms of measuring percentage reductions. So if you took a US benchmark, for instance, for a hospital, and you understand that a typical square metre carbon emission or embodied carbon rates per square metre for a hospital is 100, and you know that in the Middle East you can maybe achieve 70, 75, at least you have something to compare it to. Or if not, if it's slightly over, at least you have mitigating factors. But you do have some level of comparison. It's just that we don't quite have enough projects here in the region specific to give you absolutes.